1.30. For next, high priority. For next, click on finish. Now the virtual machine will start getting migrated. Okay. Okay, it is not allowing the current state.
It's destroyed from the other machine. The other machine.
Yeah. Let's see. Should be on shared storage. Yes. Settings. Okay, let me show you. Get an error so that you understand it. Click on migrate. Change host. Next. 1.30. Click on next. Next. Check out. Scroll down. It should give an error. Why is not giving an error? Now guys, if you see this, the virtual machine has migrated from 1.20 to 1.30. Fine, have you seen that? So this is vMotion. However, let me select a machine where it will give you errors.
Sorry, did you check the device? Is it using the local device?
Yeah, no issues with that. It should give an error. I'm just checking for a machine which will give an error to us so that we identify. Okay, we'll try to migrate this machine. It is running. Let me select a machine which is on local hard disk. Okay, fine. If you see this machine, guys, which is on 1.30, okay, I'll try to migrate it. Let us try to understand what are the errors. Change host. It is on 1.30. I'm selecting 1.20 now. Now you get these errors, right? Now, why are you getting these errors? If you keenly observe these errors, unable to access the virtual machine configuration file.vmx. The virtual hard disk is not accessible on the host.vmdk. Unable to access the virtual machine configuration, that is the file .vswp, the swap file. Why are you getting these three errors? It is because the virtual machine is on local data store. If you see this virtual machine, SSI2 big is on local data store. I told you the 5 prerequisites. What are those? Virtual machine should be on shared storage. That's the reason why it is giving errors. Then what do you have to do? if you come across these kind of issues. Then you need to go with storage vMotion. We can migrate this virtual machine from local data store to shared data store, and then we'll try to migrate it. Okay. So let us go back. As what is storage vMotion? Virtual machine running, and I'm migrating it from one data store to another data store. If I select the second option, change data store, this is storage vMotion. So first we'll migrate the virtual machine from local to shared, then we'll be able to migrate it from one host to another host. So I'm doing storage vMotion now. Storage vMotion means the virtual machine is running and I'm migrating the virtual machine from one data store to another data store. If I select this option, change data store, then this is storage vMotion, click on next. Right now it is on data store 1. I'll be able to migrate that to VMFS shade 3. Okay. And guys, in storage vMotion, while migrating the virtual machine from one data store to another data store, I can also convert the virtual hard disk. If it is thin, I can convert to thick. If it is thick, I can convert to thin. I can also convert a thick lazy zeroed virtual hard disk to thick eager zeroed, from thick eager zeroed to lazy zeroed. So how to do that? During storage vMotion operations, I can convert the disk. See,
Sorry,
by
Mujib,
default, it would be,
it might sound a very silly question, but what's the difference
yeah,
between all these types of storage?
the disk you mean to say? We already discussed this. Yeah,
Thin
I think
and thick.
I think we already discussed that in detail. The difference between thin and thick, guys. The virtual machines will have the virtual hard disk, okay, and those virtual hard disks can be of two types. The first one is thick, and the second one is thin. What is thick is that when you create a virtual machine with a virtual hard disk and select the option thick, then if I configure the virtual hard disk to be of 40 GB, that entire 40 GB space would be allocated from the data store to the virtual machine, the virtual hard disk. This is thick. So allocation is done from the data store. Okay. When you select the thin option, only commitment is done. Allocation is not done. Okay. What is the meaning of it is that I create a virtual machine and I configure the virtual hard disk with 40 GB. And if I select thin provision, then data store is not going to allocate that 40 GB to the virtual machine. It is going to commit that whenever you require, I am going to give you 40 GB. So here initially maybe that virtual machine is utilizing only 4 GB of it, 4 GB of the 40 GB, then data store is going to allocate 4 GB out of the 40 GB. The remaining 36 GB is committed. Whenever you require, I'm going to give you. But allocation is not done. Whereas in thick provisioning, allocation is done in the first instance itself. So that's the difference between thick and thin. If you go with thin provisioning, then you can utilize your storage space in a more better way. Why? Because allocation is not done initially, so only commitment is done, so I can overcommit the data. You can see the best example here, guys. If you see
How
this
about the third
VMFS,
option? Sorry.
the third option, I'll explain. In thick, there are two differences. In thick, you have lazy zeroed and eager zeroed. I'll explain that. But however, if you go with the thin option, how you can overcommit the data. See, guys, if you see this VMFS Shade 3, the capacity of this LUN or this data store is 1.98 terabyte, right? You're able to see this? 1.98. But out of which I have overcommitted. The provision is 8.3 terabyte. So that means I have stored virtual machines and I have committed 8.3 terabyte space to those virtual machines. Okay. Are you able to see this? The installed capacity is 1.98 terabyte, but my commitment is 8.3 terabyte. So this is the advantage of going with thin. Okay. And out of this 2 terabyte space, approximately 1.2 terabyte is used. Still, I have approximately 850 GB free space available. This is the advantage of thin. Now, in thick, again, if you have done thick, guys, you should have required almost 8.3 terabyte space. Okay.
Actually, if everybody using, what will happen?
That is a problem. Now, everyone requires, every virtual machine requires that much amount of space. Then I should be able to provide this 8.3 terabyte to this data store. Okay, why? Because my commitment was 8.3 terabyte. And suppose if I have configured my virtual machines with thick, then this data store size should have been 8.3 terabyte. So if you overcommit that, and if all the virtual machines demand that much amount of space, then most probably you'll be running out of space on your data store, and then you need to add space to your data store. Fine. So, or you need to migrate certain virtual machines to some other data store where you have enough space. Now, what is thick lazy zeroed and thick eager zeroed? If I drop down this, I told you while migrating the virtual machine from one data store to another data store, there is storage vMotion option. I can change the thick disk to thin, thin to thick, and thick lazy to eager, eager to lazy. Now both are thick disks, but lazy zeroed, there is something called filling out the hard disk with zeros. So lazy zeroed, if you select lazy zeroed, the filling out of the hard disk is done later. Whereas if you go with thick provision eager zeroed, now that filling out of the hard disk with zeros will occur during the creation itself. So suppose my this hard disk is thin provision. I want to change it to thick. I can select thick lazy zeroed or eager zeroed. Okay. In eager zeroed, what will happen is that the entire hard disk space, which is unutilized space, would be filled with zeros, which is called as eager zeroed. Okay.
What does it signify? Why are you filling out the hard disk with the zeros?
It is similar to like suppose in the background there is some data which has to be scratched out. Okay, we'll scratch that entire data, and there is another advantage of filling out your disk with zero is that how is the data written on the disk, guys? How is the data is written on the disk? It is in bits and bytes, right? Right, bits. So that can have a value of 0 or 1, right? That's it. So when the entire hard disk is filled with zeros, then writing operation, all I need to do is that replace that 0 with 1. That's it. If I have a 0, 0 is already there. Okay. Whenever I have to write 1, then I'm replacing that 0 with 1. So that is the advantage. So reading and writing operations will become a bit faster on either 0. Fine. So here I have the option of changing that thick to thin and thick to thick. If you don't want to change, you can go with the default option. Same format as source. Now change the data store 1 to shade 3. And click on next. Click on finish. You see this now. This virtual machine's data store. I'm migrating it from data store 1 to shade 3.
Hello?
Guys, this virtual machine, I have changed it from data store 1 to data store 3, which is VMFS shade 3. That virtual machine was using the ISO image on data store 1. I unmounted it by just right clicking and going on edit settings. And then I migrated it from 1.30 to 1.20. Now the vMotion is occurring. Okay. So I told you there are 5 prerequisites. Now we'll see how to check whether we have a VM kernel port configured for vMotion or not. Okay. So go on the host, go to the configuration tab, go to networking, and here just check out whether you have configured the VM kernel port configured for vMotion or not. If I go drop down this, it's a long switch. See, I have a port which is configured for VM kernel port vMotion and I have the IP 10.0.1.21. Okay, let me see on destination on the other host here, 1.30 configuration. Here also I have a VM kernel port configured for vMotion 10.0.1.31. Now how this name appeared, I gave that name VM kernel port for vMotion so that just by seeing that port name, port label, I should be identifying that this is the port which is being used for vMotion. Okay, now, if you don't remember how to create it, let me show you. Click on properties of that virtual switch. Under the ports tab, click on add. Now it gives you the option whether to create a VM network port group or VM kernel port. Select VM kernel port. Click on next. Here you need to give a label. So when I created that port, I used the label VM kernel vMotion. And then I check this box, use this port group for vMotion. Then this is the configuration of VM kernel port. When I click on next, I need to assign the IP. And here I have assigned the IP 10.0.1.21 on 20 host. And on the 30 host, I have assigned the IP 10.0.1.31 as you're seeing here. I click next, next, and finish. This VM kernel port was configured. So this is how we check.
Is this covered in the practical labs? Are the slides?
Yes. How to create a VM kernel port? I have shown you on the slides. You can just check it out. Okay. So this is how we create VM kernel ports configured for vMotion. And now I also told you that the the VM network port group labeling and setting should be identical. If you see this machine, let us say, what was the machine which I migrated recently? It was ESXi2 big, which was on 1.30. Now it is on 1.20. So let me go to 1.20. See, here is my virtual machine. Now, if you see this virtual machine is connected to a port group labeled production. Port group labeled production. Now, this port group labeled production should be available on my virtual switch. If you see this, I have a port group, virtual machine network port group named production on 1.20. In the same way, I also have a port group named production on 1.30. So this is what I'm talking about. Why? Because virtual machines will get connected to a port group on virtual switch. So that's the reason why the labeling should be identical on the source host as well as on the destination host. Why is that important? Now I'll explain you what happens behind the scenes when I migrate a running virtual machine from one host to another. Let us try to understand that. Okay, what exactly is happening in vMotion? Okay, let us say this is my ESXi1. This is my ESXi1, and this is my ESXi2, and my virtual machine is on my shared storage.
Hello?
So let us say that I have ESXi1, ESXi2, both are connected to my SAN, and I have my VM1, VM2 on ESXi1, VM3 on ESXi2, and these are on my shared storages. So I have VM1 and 2 on VMFS1, and I have VM3 on VMFS2. Now, guys, let us say that I'm migrating the virtual machine number 2 from ESXi1 to ESXi2. Now, where is my virtual machine running right now? On ESXi1. Okay? And my virtual machine is on VMFS1. It is on my data store 1. Guys, if my virtual machine is on VMFS1, and I'm also saying that my virtual machine is on ESXi1, what is the difference here? I'm saying that my virtual machine is stored on VMFS1, and I'm also saying that my virtual machine is running on ESXi1. So what is on VMFS1 and what is on ESXi1? We need to understand that. What is on ESXi1, guys? And what is on VMFS1 associated with that virtual machine number 2? Both the statements are true. Both the statements are true that my virtual machine number 2 is on ESXi1, true. My virtual machine is on my shared VMFS1, that is also true. But what is there on my shared, that means VMFS data store, and what is there on ESXi1 related to VM2? Are you able to understand, guys, what I'm trying to prove here? Guys, virtual machine is nothing but set of files stored in a folder, and that folder is on my VMFS data store, VMFS1. So VM2 is stored on VMFS1. There is a folder which contains all the files associated with virtual machine, and all the data is here. But what is there on ESXi1? My virtual machine is running there, right? So what type of data is available on ESXi1? I'm saying that I'm migrating the running virtual machine from ESXi1 to ESXi2. My data is here on VMFS1. I'm not changing that. I'm migrating the running virtual machine from ESXi1 to ESXi2. So that means I'm migrating something associated with VM2 from ESXi1 to ESXi2. What is that I'm migrating?
Configuration settings.
Okay, fine. Anything else?
Distributed locking.
Okay, fine. Okay, one is the configuration settings. Valid point. Agree. I'm migrating the configuration settings. Fine. Anything else? What is there on ESXi related to VM2? What is there on ESXi1 related to VM2?
That hardware.
Okay, it is utilizing the resources of ESXi1. Agreed. But what type of data is available on ESXi1 related to VM2? The entire data is here, but there is some data on ESXi1. What is the data? What is the data, guys? Okay, let me ask a question in a different manner. Fine. Now, guys, suppose you have installed your operating system on a physical machine. Okay? Where is the data? If you have installed your operating system on a physical machine, where is the data?
Local hard disk.
On the local hard disk. Fine. Agreed. Now, when you boot your operating system, what happens? If you're booting an operating system on a physical machine, what happens?
Loads the files.
what happens, guys? Prior to booting, all the files, all the data is on the hard disk. Now, once you boot your operating system, what is happening is that all the files associated with that operating system are getting loaded to the memory. Agreed? Agreed, guys?
Yes.
And whatever, yes, to the memory, that is your RAM. Now, whatever the applications you load, you open, all the files associated with that particular applications are loaded to the memory first. From there, it goes to the processor for processing. First, the input goes to memory. From that input, it goes to the processor. Processor processes it. It gives the output. Again, that output is stored in the memory. Agreed?
Yeah.
So that means whatever the processes associated with that particular operating system are running on that particular machine, and every data is on memory unless and until it has been saved onto your physical hard disk. Clear, guys? So here also,
Yeah.
what is there on ESXi 1 related to VM2? It is nothing but the virtual machine's processes. The entire virtual machine's processes are on ESXi 1, and that is stored in the memory of ESXi 1. Guys, I told you that whenever a virtual machine is powered on, ESXi is going to allocate a contiguous memory space to the virtual machine, and all the files associated with virtual machines are loaded to that contiguous memory space. Am I right?
Yeah.
Do you remember this point? So that means on ESXi1, it is nothing but the processes of the virtual machines are running. So that means each and every file associated with virtual machine is on ESXi1. Now, if I say that I am migrating a running virtual machine from ESXi1 to ESXi2, what exactly I am migrating? I am migrating the virtual machine's state from one host to another host. What am I migrating? I am migrating virtual machine's state. This virtual machine state includes two information. The first one is memory state. That means whatever is there in the memory, I am migrating that from ESXi1 to ESXi2. First, the memory state is getting migrated. Second, I am migrating the hardware information of the virtual machine. So hardware information means the configuration information. Okay? The hardware state and the memory state, or the configuration information or the memory state. So when I say that I'm migrating a running virtual machine from one host to another host, I'm migrating the virtual machine state information from one host to another host. That state contains the memory state. That means all the files associated with that virtual memory, with that all the files associated of that virtual machine, which is stored in the memory. That entire thing is getting migrated, as well as the configuration information of that virtual machine is getting migrated. So when I start this virtual machine's migration process, what happens is that all the files associated with this virtual machine, which are in the contiguous memory space, all the files, that is the memory state, get started migrating. Slowly these files will be moved to the ESXi2's memory. Slowly they're getting migrated. Slowly
Suppose if
files are
in
getting
the
migrated.
destination host that the contiguous memory applications are not available, means what will happen?
If there are no enough resources, then there is a separate scenario. Okay? You might
Yeah,
find,
if the
you
resource
may
is
face
there,
problems.
but they are
Okay.
not contiguous. Suppose first
No,
some
it is a process.
some 1
It is
GB
a
in
process.
starting.
It is a process of ESXi that it always allocates contiguous memory space. It will create that space for that. Okay. So whatever may be the case, it is going to create that contiguous memory space. All right. So here, guys, is my virtual machine running? Yes, it is running. So that means there are continuous changes being occurred. Agreed? Now I'm migrating the virtual machine's memory state. That means the files are getting migrated from the memory of ESXi1, and they are getting loaded to the memory of ESXi2. And my virtual machine number 2 is running on ESXi1 continuously, and there might be certain continuous changes being occurred. So that changes has to be tracked, and the changes are tracked in a file called memory bitmap file. It is called as bitmap file. So what are the changes which are being occurred? It is being tracked in a memory bitmap file, and the other files which are not being changed will get migrated to the ESXi2. When almost all the memory state information, let us say 98% of the memory state information got migrated from ESXi1 to ESXi2. Now, the last memory state information, which includes the bitmap file, has to get migrated. Bitmap file is important. Why? Because it is keeping the track of all the files which are being changed or the continuous changes which are being occurred. Now, I need to migrate this file. If I'm migrating this file, then who is going to keep a track of the changes? Why? Because virtual machine is running. So here at this moment, I require a breathing space. I require a small time gap so that I can migrate the final memory state information. 100% I should be able to migrate it to ESXi2. During this time, I require slight time. Okay, why? Because continuous changes should not occur. If continuous changes are occurring, I will not be able to migrate the last portion of the memory state. So here comes the process which is called as squeezing of input-output operations on the virtual machine.
Rajiv, can you explain that bitmap file
Yes,
concept again, please?
squeezing of input-output operations occurs on the virtual machine. Okay, now bitmap file will keep a track of the changes which are being occurred. Okay, when you start migrating the virtual machine, the memory state information gets started migrating, and almost 98% of the memory state information gets migrated. The only portion left over is the changes which have been occurred, and I need to migrate that portion. If I want to migrate that portion, then who is going to keep a track of bitmap? That means who is going to keep a track of the changes which are being occurred? That means I need to get certain time where no changes has to occur, and I should be able to migrate that file totally. 100% of the memory state information has to get migrated. So that means no changes has to be occurred on that particular virtual machine. So what I can do at that particular time, I can squeeze input-output operation on that virtual machine. Squeezing is nothing but pausing. There would be a slight pause for the input-output operation on that virtual machine, and that would be in for fraction of seconds. During that fraction of seconds, this last information, the last portion of the memory state, the entire thing gets migrated to ESXi2. Now, during that squeezing operation, what happens is that entire memory state information gets migrated to ESXi2. The configuration information gets migrated to ESXi2. The configuration information, this entire hardware information gets migrated to ESXi2. And during that time, VM2 is now registered with ESXi2. Now this virtual machine is no more here. Now VM2 is registered with ESXi2. And immediately that squeezing is stopped. That means pause will be removed. And what will happen is that the VM2 is now running on ESXi2 without any interruptions to the end user. There is no network loss, there is no data loss. The squeezing, that means the slight pause on the input-output operation, is for fraction of seconds, and during that fraction of seconds, the last portion of that memory state information and the configuration information gets migrated, and the virtual machine number 2 gets registered with ESXi2, and immediately everything is fine. Okay, now we need to understand one more thing, that while the virtual machine was running on ESXi1, all the traffic related to VM2 was traveling to ESXi1, right? Now the traffic has to travel to ESXi2. So how does the network knows that now this virtual machine is on ESXi2? At the final, when the virtual machine gets registered with ESXi2, what happens is that there is a protocol which is run across, which is called as RARP. Guys, you know about RARP? What is this protocol?
Address resolution protocol.
Yeah, ARP is address resolution protocol, and RARP is a reverse address resolution protocol. ARP resolves the IP address to the MAC, whereas RARP resolves the MAC address to the IP. So at the end, we are informing the network that the MAC address of VM2 is this and it is here. So what will happen is that whatever the traffic which was in the wire will get rerouted to ESXi2, and my VM2 is live without any interruption. Previously it was on ESXi1, now it is on ESXi2. So this is the entire process which happens behind the scenes in vMotion. And we need to understand one more thing, guys. The fourth prerequisite. What I told you, the fourth prerequisite, the virtual machine's network port group labeling and settings should be identical. Why it is important is that, guys, my virtual machine number 2 was on ESXi1 and it was connected to a virtual switch on ESXi1. When I'm migrating this virtual machine, I cannot migrate the virtual switch, right? Can I migrate a virtual switch? No, I can't migrate a virtual switch. Now, can I migrate that port group which is available on that particular switch? No, I can't migrate a port group. Then what can be done? I can do one thing, that virtual machines always get connected to port groups. Now that information is there in the configuration of that virtual machine. The configuration information got migrated. So what I'll make sure is that on the destination host, I'll make sure that the same port group exists on destination host. When there is the same port group available with the labeling and setting, the virtual machine will get connected there, but because the configuration is set to get connected to that particular port group, now without any issues, my virtual machine is running on ESXi2. That's the reason why the fourth prerequisite is important. Why? Because I cannot migrate a switch. Why? Because virtual machines will always get connected to switch, that too on a port group of a switch. So I cannot migrate the virtual switch nor the port group, but I can make sure that the same port groups exist on the source as well as destination, so that when the virtual machine gets migrated to the destination host, it gets the right settings of networking so that it can perform without any issues. Did you get the concept of the fourth point, guys? Why it is important to have the port group labeling and settings identical? Clear? Clear, guys?
Explaining it again, please.
Could you repeat?
Mind explaining it again, please?
Which one? Which part? The port group labeling?
Last part.
The port group labeling, guys. Virtual machines will be connected to a port group on a virtual switch. Am I right?
Yeah.
Virtual machines will always get connected to a port group on a virtual switch. Okay. Now I'm migrating this virtual machine from one host to another host. I cannot migrate a switch. Why? Because switch is owned by ESXi. Okay. So when the virtual machine gets migrated from ESXi1 to ESXi2, it needs to have the same settings on ESXi2, the same port group labeling and settings. If it has it, then it will get connected to that particular port group with the settings, and there wouldn't be any mismatch in the configuration, and the traffic which was coming to that virtual machine will reach the virtual machine. Let me show you here. If you see this virtual machine ESXi Raj, it is using the port groups prod and VM network. Okay. If I go to the virtual switch, you can see this ESXi Raj is connected to the port group called prod. Okay. Now, if I migrate this virtual machine, as this is connected to this switch, I cannot migrate this switch nor this port group. I am only migrating this virtual machine. Now, this virtual machine is configured to use the port group prod. Now, on 20, I need to have the same port group prod. Okay. So what will happen when this virtual machine ESXi1, ESXi-Raj will get migrated to 1.20? This port group is available, so it will get connected here without any issues. So that's the reason why this port group labeling and settings are important. Suppose this port group is not available on 1.20, then the virtual machine cannot migrate, but because it doesn't have the same infrastructure or it doesn't have the same environment on the destination host. But because virtual machines will get connected to port groups on a virtual switch, and I cannot migrate the virtual switch nor the port group, but I can make sure that similar kinds of settings are available on both the source host and the destination host. Clear with the point? Clear?
Yeah.
Yep. So this is all about your vMotion, guys. This is what happens behind the scenes when you perform vMotion. In vMotion, We are migrating a running virtual machine from one host to another host. What exactly are we migrating? We are migrating the virtual machine state, which includes the memory state and the configuration information of the virtual machine. That means the hardware information. Okay. So this is about vMotion. And now let us try to understand storage vMotion. Guys, storage vMotion also uses the similar kind of technology of vMotion. Okay. Uses the same technology as vMotion. However, in storage vMotion, what exactly we are doing? We are not migrating the virtual machine from one host to another host, but we are migrating the virtual machine's files, which are stored in a folder from one data store to another data store. That means that entire folder is getting migrated from one data store to another data store, and that too while my virtual machine is running. It is in running state, and I'm migrating the virtual machine's files from one data store to another data store. Okay, and when I migrate that, the data store can be any different storage types. For example, local data store to shared data store, or it can be from VMFS data store to NFS data store, from NFS to VMFS, from shared to local, local to shared, whatever it is. So you can migrate from the virtual machine from different storage types, not an issue. Now, what is the component used in storage vMotion? Here, guys, on your ESXi host, you have a component which is called as VM kernel data mover. So VM kernel data mover is used to migrate the virtual machine files from one data store to another data store. Okay, and you have some other component which is called as VAAI. Now this depends on your storage. That means your SAN needs to support this VAAI. Now VAAI stands for vSphere Storage API. VAAI. It stands for vSphere Storage API Array Integrator. Okay, this is called as VMware vSphere Storage API Array Integrator. If your SAN supports it, then ESXi is going to use VAAI for migration. If your SAN doesn't support, then ESXi is going to use VM kernel data mover. Okay. Now let me show you with the help of this figure how storage vMotion occurs. Okay, guys, in storage vMotion, we are not migrating the virtual machine from one host to another host. Rather than we are migrating the virtual machine's files from one data store to another data store. So let us say this is my host. Okay, and my virtual machine, let us say, is on my VMFS shared 1, and I'm migrating it from shared 1 to shared 2, let us say. These are my two data stores. Okay, so host is the same. This is the same host. This is my ESX. I'm not migrating the host, but I'm migrating the data store. Okay, so this is my VMFS 1, let us say, and I'm migrating it to VMFS 2. So I have the virtual machine VM1 running on ESXi 1. Okay, and the folder on my data store. Here, what I'm migrating basically, this folder VM1, I'm migrating it from from VMFS 1 to VMFS 2. And what is used here? VM kernel data mover. So what is happening here is that this is getting migrated in this way. The entire folder VM1 is getting migrated from VMFS 1 to VMFS 2. So during the migration operation, VM kernel data mover migrates the folder, the entire folder, that means the files associated with this virtual machine VM1 from VMFS1 to VMFS2. When I start this particular process of migrating the virtual machine files, that is storage vMotion, I have this VM1 running. In the background, there is another process of VM1 which gets started. VM1 gets started. So what happens is that why this new VM1 is getting started, this VM process is getting started, is that the data is getting migrated from this folder to this, from this data store to this data store, and my virtual machine is running. Okay, it is writing the data. The original one would be writing to this folder. This new process would be writing to the destination, so that there is no discrepancy in the data in that way. And in the background, there is a mirror driver which is going to mirror and see that the source and the destination, the data is the same. Okay, so in this way, in the background, a new VM process gets started, and till the time this entire folder gets migrated to VMFS2, this in the background the virtual machine is running, and once that entire folder gets migrated, okay, this process gets cured. All right, and this folder is
Hello?
Hello.
I think he lost the power connection.
Yeah.